Steps. I'm Lasya.
And I'm Kritika, and we're your trainers from Future Steps.
Today, we'll be looking at geometry of shapes and geometry of like different lines and what geometry is basically.
So let's get started. So let's start off with our first. Let's see. Okay, so geometry is the study of shapes and sizes. Let's start off with talking about simple geometry. So we know that there are points, lines, and planes. So a point is basically just just a dot. That does not look like a dot, but we're going to say that's a dot. So that is a point. A point is a location in space. It has no size, and like I said, it's represented by a dot and a label. So a label would be something like it's kind of like a coordinate while you have it on a graph. So if we have a point on a graph, it would be something like 1, comma 2, or we could just name it by A. So that is what we call a label. And then a line is just a straight path extending in both direction to infinity. So just that, both of these sides, and an arrow represents going to infinity. So that is a line. And then a line segment it looks just like a line, except, oh, that was my fault. Let's see, okay, I can't go back, can I? Okay. Oh, well. Okay, there we go. So a line segment is basically a line, but it has two ending points. So the ending points, I'm gonna have them as two small dashes. So let's call this point A and point B. So this line segment will be called line segment AB. And that is how you write line segments. And then if we have array is where, let's say we have a point. Array is when there is a line coming out of a point. So it'll look something like this. And the other end will go to infinity. And then a plane is just a flat surface that extends without any end and in all directions. So when we mean a surface, we mean something like, let's say we have this. This is our plane, and all of these go up forever. So this is what a plane would look like, and in a plane we can have lines, line segments, rays, points, everything. And these planes, if you ever look at these digitally, you can rotate them and see that no matter what you do, they're never going to have an end. It's just like a blank sheet going up to infinity. So we can have points in here. So let's say this is point B. We can have lines coming out of here. And we could also have line segments. It depends. And a plane, since it goes to infinity, no matter what you do, you can have whatever you want in there. So that is all for points, lines, and planes. So we'll move on to shapes now.
Okay, so there are four different types of shapes we're gonna look at right now. They are 2D, 3D, regular, and irregular shapes. So let's look at 2D shapes first. So as you can see in the photo here, we have some examples. We have a circle, a semicircle, triangle, square, and so many on, right? It goes on. So what's the similarity between all of these and why are they called 2D shapes? Is because they're flat. Like if you compare it with the 3D shapes, the 3D shapes, they have like a volume or like they have like some gap in between them to make them look more realistic, right? Whereas 2D shapes are just things like that we draw, right? They look like flat, like this piece of paper. It looks like flat like this. It's similar to that. 2D shapes is flat compared to this phone. has a volume in here, which has like some like thickness there. That's the difference between 2D and 3D shapes. And in 2D shapes, we can name them differently. So for example, square, of course, it has four sides. You call it a square. But like any like a shape, a 2D shape with like four sides, you can call them quadrilaterals. So squares, rectangles, parallelograms, all of these are rhombus, all of these are quadrilaterals because they have four sides. And if you have five sides, it's pentagon. So the way I remember is that a gon is there for every single one of these shapes that have like different numbered shapes, right? A gon is like the ending. So something, and then we have a gon as the ending. That's the way we name these. And then penta in like Latin, I think, or Greek, it's called five. So you just say penta, which is five, a gon, which is five-sided polygon, a five-sided shape, sorry. And then you have hexagon, which is hexa is six and a gon. If you have six sides, you call it hexagon. And seven side, you guessed it. Hepta is seven and you add a gon. It's heptagon. Eight, same, right? Octa is eight and you add a gon, octagon. And nine is nona, you say nonagon. And then finally, for now, at this range in middle school, like 5th to 7th grade, you would know until 10-sided shapes. These are called decagon. You add a gon at the end again, decagon. And then we have all, and then trapezoid and all of so. These are the new, like, most important things you need to remember of 2D shapes. Now let's move on to 3D shapes. So like I said before, these have a little volume to it, right? Like unless 2D shapes, they have something like to the side, like they look more realistic, right? They look like you'll have them in real life, like your phone, it has some volume to it, your laptop, it looks realistic, right? Rather than drawing them like 2D shapes, that's a triangle, right? But in 3D shapes, you have a square pyramid that has more volume and it looks like the triangle is like, extended to make it into a 3D shape. So we have different types of 3D shapes, of course. We have cuboid, cube, a sphere, a cylinder, cone, square pyramid. It's called a square pyramid because its base is a square. And then hexagonal pyramid. Hexagonal, remember, hexa is six, agonal is the ending, and it's six-sided shape. So it's a hexagon-based pyramid. And then we have a triangular prism and hexagonal prism. So the difference between this is a prism has like rectangles, right? And the pyramid has triangles connecting the sides together. Yeah, and later on we'll have other videos in our playlist for math where we talk about how to find areas and volumes for these shapes. Now let's look at regular and irregular shapes. So regular shapes have like you can name them easily. This is a triangle, a pentagon, and so on, right? A square and so on, right? Whereas the irregular polygons, they have like shapes you can't like actually name. Like you can't name this, right? And this is only in some instances. Like this, you can name it, of course, rectangle. But like the most important thing is like one of the points you need to remember of irregular polygons is it's hard to name them compared to others. And this is not a normal triangle, so it's hard to name it. But this is like a scalene triangle, right? But that's like for other in another case. But for most of the time, just remember that it's hard to name them. And another important thing to remember about the difference between regular and irregular polygons is that regular polygons, they have the same length of sides. So this is the same length, that's the same length, this is the same length, same length, same length, same length, and it goes on, right? They have the same length and they connect with one another. But then for irregular polygons, you don't have the same length because this and this is the same, but like this, these are different. These two are different than these lines. So that's irregular, right? And you can say this and this is the same, but this and this is not the same, right? That's how you say that they are irregular polygons because you won't have all the shapes being the same sides and so on. Same length sides, sorry. And that's it. That's it. That's all you need to know for 2D shapes, 3D shapes, regular and irregular polygons. And next, we're going to look at angles.
Okay, so let's talk about angles. Now, we know that angles are formed when two rays meet at a point. So I kind of just drew it right up here, which let's zoom into it. So we saw that on this plane I drew a point and I kind of just drew a ray and a line segment, but let's call this a ray too. So let me just redraw this. So for angles, an angle is when there is a point, and from the point we have two rays coming out. So this is what we will call our angle. Okay. And now there are different types of angles. So there's something called the acute angle. So what I just drew here would, so let me just zoom out and draw, let me erase all of this so that we can actually see it better. So let's get this out of the way. Now we have different types of angles. We have four main types of angles. And there are definitely more than that, but there are four that we must know. So there's the acute angle, which is a point. So we have a point, and then we have two rays coming out. That's an angle, right? An acute angle is if the angle is less than 90 degrees. So this angle, let's say it's 40 degrees, it's less than 90 degrees, so it's an acute angle, and it's greater than 0 degrees, because you cannot have a negative angle ever. And then a right angle is exactly 90 degrees. So something that looks like this would be a right angle. And then an obtuse angle is something that's greater than 90 degrees but less than 180. So an obtuse angle would look like this. So let's say this is 120. It's bigger than 90 degrees, but it's less than 180. And then a straight angle is basically the angle of a line. So that was not quite a straight line. So here. So this is 180 degrees. And it kind of looks like a semicircle. And a semicircle is 180 degrees because a full circle would be 360. There's also something called a reflex angle, but you don't need to know much about that because it doesn't usually come. But if you did want to know about that, a reflex angle is something that's bigger than 180 but less than 360. And then that's because if it were to be 360, it would be a full circle. And greater than 360 would just overlap the circle. So that is all about angles. Now we're going to move on to angle relationships.
So these are things you would need to memorize to get better at solving geometric problems. So complementary angles add up to 90. So 45 plus a 45, for example, they add up to 90 degrees. So that means both of these angles are complementary angles. While supplementary in another case add up to 180. So let's say you have 130 degrees and then you have a 50 degrees. They add up to 50 degrees, 180 degrees. So they are supplementary angles. And usually you find them in co-interior angles. So what I mean by that is when you have two parallel lines and there's a line going through them, and then you have two angles inside of these, right? Those two angles. they would add up to 180 degrees, and so they're called supplementary angles. And if you want to learn more about this, we have another video in our playlist for maths grades 5 to 7, where we talk more about angles and geometry of shapes. And then we have not shapes, but geometry in specific. And then we have vertical angles. So these are opposite angles formed by two intersecting lines and are always equal. So basically, when you have two lines intersecting one another like that, and then you have an angle here and here, but basically both of these are the same, and the angle here and here are the same. Yeah. And you can also make another observation that if you look at this line here, right? So you can say that everything here adds up to 180 degrees because it's a straight line angle. And then we have adjacent angles. These share a side and a vertex. So what do they mean by that? Is basically, let's say you have a sphere, right? And then you have an angle here and an angle here. Of course, they would be 90 degrees, right, for a square. These both are adjacent angles because they share the same side and they have a vertex, right? That's why they're called adjacent angles. While this and an angle here, for example, these both won't be adjacent because they don't share the same side, right? Because this shares this side and this side, but this angle shares this side and this side, so they can be adjacent angles. And then we have linear pairs. These are adjacent angles that form a straight line. So you can say this is a linear pair because they form a straight line and they are adjacent angles. And finally, we will look at the last topic, which is symmetry.
Okay, so let's get into symmetry. Also, another great example of adjacent lines. Oh, wait, I kind of just deleted a small portion, but that's okay. So another great example of adjacent angles is if we have just a triangle and we have something bisecting a triangle, these two angles would be adjacent. So that's one great example too. And linear pair would be just a line, something like that, and two adjacent angles that add up to 180. So that's one way you can visualize it. You could also visualize it the way Lasya told you to. So now let's talk about symmetry. So we have two different types of symmetry. We have line symmetry and rotational symmetry. So line symmetry is one half is the mirror image of the other. So what that means is if we look at a plain butterfly, so I'm not good at drawing, but we're gonna say this is my very nice butterfly, okay? Let's say it looks the exact same on both sides. If I cut through a line, that was not good. If I cut it through from the middle, then one of its sides should be, so this side should be the same as this side, right? So that is what line symmetry is. And that also works in graphs. So for example, if we, okay, let me erase this. So for example, if we had something like, we have this and then we have a graph that looks like that, this is a symmetrical graph because if we draw a line from the middle, so let me change my color, and if we draw a line right here, then both of these sides will be the same. So this side and this side look exactly the same, right? Now let's talk about rotational symmetry. So let me erase this again so I can use this part. So now let's talk about rotational symmetry. Rotational symmetry is basically a shape that looks the same even if you rotate it to another side. For example, if we look at a cube, right? So let's make our typical looking cube that looks somewhat like that, right? So that is our cube, okay? And if we turn this, so let's look at this cube from its top view. If we look at it from the top, it's going to look like this, right? If we look at it from the side, it's going to look like this. If we look at it from the bottom, it's going to look like this. There isn't really a difference between how it looks. So this is something that shows rotational symmetry. So no matter what side I rotate a cube to, it's going to look the same because all of its sides are the same. And a lot of this also goes with prisms, and it depends on how you rotate it too. So for this, no matter what side you rotate it on, it's going to be symmetrical. But if it was something like a rectangular prism, then there'd only be one sort of way you can rotate it for there to be a sort of symmetry. So that's what rotational symmetry means, and line symmetry is what you usually see. Rotational symmetry doesn't come up as much, so we don't have to go too much in depth, but the best example would be a cube. It's the best example for almost everything. So that's what we have for symmetry. Also, some real world examples would be some architectural designs. They have rotational symmetry such that if you drive around it, it looks the same from all sides. And that's kind of like what most buildings look like. If you go to, like, let's say Chicago downtown, you're going to see a lot of buildings, and many of them, if you keep driving around them, it looks the same. Until you go on the riverside boating, and you're going to see different types of buildings which are not symmetrical. So that's one example that you could see in real life. And guys, geometry is really important because most of the things that are built using geometry, such as the house we live in. You could just go to the edge and you can take out like a sort of protractor or something and kind of just measure the edges. Or you could take out a ruler or anything at all, and you could kind of just look at the angles and you could see, oh, well, there's geometry in this. There's geometry in everything. Just pick a ruler and go around measuring things. You'll find some geometry in there. So that is all we have for you today. A, a small summary would just be geometry is a study of shapes. Point is a dot with a label, such as point A or point B. A line is just a straight line that goes forever. A line segment is a line that has a measurement. A ray is a line that goes forever from one side and has a point on the other side. There are different types of angles. There's acute, right, obtuse, and straight. There's also reflex angle that we don't need to know about, but just mentioned it. There are different angle relationships, such as complementary that add up to 90, supplementary that add up to 180. Vertical angles are, like Glasia said, if there are two lines that are intersecting each other, so you can just make a cross on your hand, then the the angles that are opposite to each other are going to be equal. And the adjacent angles are if the angles are right beside each other and share a line and have a vertex. Linear pair is just adjacent angles that form a 180-degree angle. And then symmetry is line symmetry. For example, a butterfly, you draw a line, it's the same from both sides. And rotational symmetry is no matter what side you rotate it to, it looks the same. 2D shapes are flat, 3D shapes are not flat. Oh, wait, a great example would be if you have a stack of sticky notes, and let me just take this one for example, and I take off one of them. So this one sticky note is a 2D shape. It's flat, but it's a shape. But on the other hand, the entire stack, it has a sort of thickness. So it's the same shape, just a 3D version of it. And then Lasia mentioned a great point for regular and irregular shapes, which was for regular shapes, they all have equal sides, and irregular shapes, they all have different side lengths. Probably the main point of the shapes. So remember that, and that is all we have for you today then. We went over everything. I gave you the shortest little summary as possible, which I think I included all the main points, so that should be fine. And remember, if you are ever confused on anything, you can always comment down any questions you have or anything at all. And if you're still confused, you can always go back in the video too and look over it And after that, if you're still confused, obviously you can come to us for help. We do look at all of our comments, so we will be looking at yours for sure, and we will reply to it too. So don't be shy, comment down below. The comment section is just a free section for all of your questions, or just a free section to just say good job to us or to your fellow peers from another nation. So that is all we have for you today. See you in our next video then. Goodbye.
Bye, Stepsters.